This is part 2 of lesson 11.4. In this video, we're going to focus on composite figures, finding the area of composite figures. So they give a couple examples here. It's pretty much, and I don't say this lightly because I know not everybody's a math person. We don't all love math. It doesn't come to everyone the same way. But if you know how to find the area of any two-dimensional shape, this is kind of common sense along those lines. So, here we would obviously, if we wanted to find the area of just the shaded region, we would find the area of the rectangle and subtract the area of half of a circle that's created here, right? Over here, we would find the area of this rectangle, and then we would subtract the area of each of the 3 circles, and that would give us the area of just the shaded region. So we have, looks like 6 composite figures down here to find the area of. There's no aha moment or special trick. It's just literally putting multiple shapes together to come up with a total area of a composite figure or a figure made of multiple shapes. All right, so number 1 here, and I don't have a ton of room. I have extra paper if I need it. We've got a rectangle. So area of a rectangle is length times width, 34 times 15. And then plus, we're going to add on this little circle piece down here. Now, it's only half a circle. This is the diameter, so it's this half. So for a circle, it's pi r squared. So we need to know the radius. The diameter is 15. The radius is half of that. So pi times the radius, half of 15, squared. Okay, so these 2 things together are going to give us our total area of the rectangle and half the circle. So all you need is your calculator to multiply this out. 34 times 15 is 510. And 7.5 squared times pi is 176.7. So added together, that's 686.7, about, we're rounding to the nearest tenth, 686.7, and that's in square feet. Don't forget your units of measure. Okay, so composite figure area number 1, done. Number 2. All right, so for this one, for number 2, there are 2 parallelograms here. How do we know they're parallelograms? Well, we can see that we have vertical lines here. They look vertical, and the distance from this line to this line is this length, and this is the same as this. So if they're the same distance, then that means they have to be parallel to each other. Same thing over here. This line we know is parallel to this line because it's the same distance from each other from each end, right? Same distance here, so they're parallel. All right, so for a parallelogram to find the area, we multiply the base times the height. It gives us the length from here to here is 40. So the height of each of these, this is right in the middle since these are both congruent. This is in the middle, so this 40 gets split up into 20 and 20. So this height is 20 and this height is 20, right? And we multiply length times width, or length times height, to find the area of 1 parallelogram. So for this guy over here, we're going to multiply 24 times 20. And then it's the exact same thing as this one over here. So really, we're just doing this twice. So we're going to multiply it by 2. Okay, and at the end, we need to remember it's all in inches. So then we can multiply 24 times 20 times 2. Equals 960, and that's in inches, and they're square inches since it's area. Okay, number 3. Here's another composite shape, and we have 2, it looks like 2 triangles here. So to find the area of 1 triangle, we multiply base times height times 1/2, right? 1/2 base times height. So we're first going to think of, let's see if I can highlight it if I have my hair. We're first going to think of just this triangle on this side, just this guy. And we're going to multiply 1/2 base times height. So the base is 38, the height is 14. So 1/2, 38 times 14. And then we're going to add that to the area of this other triangle. Let me scoot this over, which is going to be 1/2. Base is 40 times the height, which it tells us is 10. Okay, so now we're just going to simplify that. 38 times 14 equals times 1/2 or divided by 2 is 196 plus 40 times 10 times 1/2. Uh-oh. Oops. 200. So 196 and 200 is 396, and that's in centimeters squared. Okay, so the area of this whole composite shape here is 396 square centimeters. All right, next one, it looks like we have a square or maybe a rectangle, no, square and a triangle. So first we can find the area of the square. We're gonna multiply 22 times 22. We know this is 22 because it's marked congruent with these little hash marks or like little double marks there. 22 times 22 is the area of our square. And then for our triangle, again, it's 1/2 base times height. We know the base is 22, so we need to know what the height is, right? Well, if this is 22 and this entire thing is 42, 42 minus 22 gives us 20. So 1/2 base times height. 1/2, 22 times 20. And when you're multiplying, it doesn't matter what order you do it in, okay? So we're gonna add those together. 22 squared is 484 plus 20 times 22 divided by 2 is 220. And then when we add those together, we get 704 maybe? Yep, 704. And that's in centimeters squared. Okay, so we just added this and this. Seems easy when you break it down, right? Next one, we've got this funky shape. All right, so these are two trapezoids. Remember to find, and they're twisted sideways, right? So the parallel sides of a trapezoid are the bases. So this is a base, and this is a base. And over here, same thing. This trapezoid, this is a base, and this is a base. So remember, we have to multiply 1/2 base times height for the area of a trapezoid, but we're gonna add the two bases together, right? So 1/2, I'm just gonna focus on this guy first. 1/2 base times height. The base is our 20 plus 40. And the height, I don't really know, it doesn't say, this is 20, this is 20, this is 40. So it looks like maybe this is in the middle. I think for this one, I'm just gonna assume that this is exactly in the middle. It appears to be, you can't normally assume, but I'm gonna assume that for this one. So if this is 64, I'm gonna assume the height here is half of that, which is 32. Same thing over here. The height of this one we're gonna say is 32. So 1/2, the base is added together, times the height. And then we have to add that to the area of the other trapezoid, which is actually the same thing, right? So we could actually multiply this entire thing times 2, because there's 2 of these. That's what I'm gonna do, times 2. Okay, so now we can simplify. This 1/2 and this 2 are gonna cancel each other out. 1/2 times 2, they just cancel each other out. So they're gonna go away. So I've got 20 plus 40 times 32, that's 60. Times 32, which is going to be 1920. And that's in meters squared. All right, one more. We've got these two triangles here, 1/2 base times height. These are parallel lines we can see. The height here is 15. Since these are parallel, they're these intersecting lines right here are gonna meet, we're gonna stay right here halfway. So this is, the height of each of these is gonna be 7.5. And so we're gonna multiply 1/2, 35 times 7.5, and then there's 2 of these, so times 2. So 1/2 base times height, and then there's 2 of these. Okay, and again, since there's 2 of them, there's just one triangle, we'd multiply by 1/2, but now there's 2 of them, so this 1/2 times 2, they're gonna cancel each other out. And we're left with 35 times 7.5, which is 262.5. And that's in yards squared, square yards. Alrighty, so if you have any questions on that, let me know.